degrees and radians.
You said
Yeah.
Okay. Let me see.
Oh, and then like the half angle formulas are kind of confusing me.
Haha. We hit the lights. I want to go away. All right, whatever. Y'all can see that, okay? All right. Ooh, we're good. All right. So the first one we're going to look at, we are given this triangle. What information am I given? This is side with an angle in between and another side, right? This is side, angle, side. This is a sassy triangle. How do I solve sassy triangle? Law of cosines, right? Everybody got their flow chart? Where's your flow chart? You're going to have to know how to use it. You got it? Okay, cool. All right, so we got a sassy triangle. We love cosines. What does law of cosines tell me to do? For a sassy triangle? Found the missing sign using the law of cosines, right? What angle do I have? Okay, we'll call it C. So I'm going to find side C, right? So I'm using C squared equals A squared plus B squared minus 2AB cosine of that angle C. And I know the other two sides. I know the angle. So all I'm solving for is C. Plug it all in. So I get C squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of 143 degrees. I could plug this whole thing into a calculator as is, making sure I'm in degrees. And then, how do I get C all by itself? Take the square root. There you go. All right, so what do I have? I have 49 plus 144 minus 2 times 7 times 12 times cosine of 143 degrees. I don't know why I got 327. What'd y'all get? 18.09. Anybody else? What else?
Well, yeah, just
Oh, yeah, you're right. You're right. You're right. You're so good. You're so good. Okay. I want to take square root of the answer. Oh, shit. No. Hey, sweet. Okay. So we get that C is equal to 18.09. So C is approximately 18.09. So this is 18.09. All right. Now what does it tell me?
find the smaller angle using law of sines.
Find the smaller angle using law of sines.
Yes.
All right. What's my smaller angle going to be? Whatever's corresponding to 7. Y'all are so good. That's why I usually label them. I'm going to call that B. I'm going to call that A. So we need to find angle B because this is a smaller one, right? And I use law of sines to do it. I know angle C and side C, so that will definitely be in my ratio. And I want to know angle B, so I'll be using 7. So I'm going to set that up. I'm going to have sine of 143 over 18.09 equals sine of B over 7. How do I solve it? Cross multiply. So I'm going to multiply these two together. Equals. I'm going to multiply these two together. And then what am I going to do? By. Well, 18.09, right? Because I'm going to get 18.09 something times sine of B equals sine 7 times sine of 143. And I want sine of B all by itself. So I'm going to divide both sides by 18.09. And now you see inverse, right? I'm looking for the angle. I need angle B. So to get rid of sine, I use the inverse. So B is equal to sine inverse of 7 times sine of 143 over 18.09. $13.47. Anybody got to confirm? Yeah. 46.
47 is 46.2. 466.
466. 466. You want to put it back in there and see? Make sure you're in your grade.
I got 13.46197. Yeah, I just got something wrong.
All right, so 13.47.
Yeah.
13.47 degrees. Sweet. So I'm going to come back up. This is 13.47. And now we can find that last angle, right? How do I find that last angle? Subtract from 180. So angle A is 180 minus 143 minus 13.47. So angle A is approximately what? Tell me again.
23.53.
Can I get a confirmation? Sweet. All right, cool. So we found all the missing angles and the missing side. Jenny, we good? Perfect. Questions about that? How we solved that using that flow chart? Think about what we got. Good deal. You always wear glasses? No? Looks good on you. Looks good on you. I know you do, Quan.
I'm so confused.
Yeah, you always got glasses on. We don't, and I like them. They're clear. Stop. Look at him. Stop.
So I have a question.
Yes, sir.
How do you make sure it's not a SAS and not an ambiguous? Like, it's the way we read it on the.
Yeah, it's the way the triangle's set up. So
Yeah, but how do you tell like this type of
I got you. That's why I say the first thing we do is draw a triangle. See what we got. So let's say that we have. Oh yeah, my bad. There you go. So here's A, B, C, A, B. All right, so I got three different triangles up here with different information. Okay, looking at this first one, I have two sides and an angle, right? Okay, two sides and an angle. Where is the angle? Is it in between my sides, or is it on the right? If I had this angle right here, I would have a sassy triangle, side, angle, side. That's not what I have. That angle is not in between my sides. So I have two sides and then an angle, right? So this is two sides. Shit. I'm really going to stop saying that. I'm sorry. Shoot. Go. So this is an ass problem, right? I got two sides and the angle that it's not in between them, right? Is that okay? Yes. Okay. All right. What do I got going on here? Right? I have two angles and a side. Where is the side? In between the angles. So this would be angle, side, angle, right? You're looking at what type of information you have is directly based on the location of the stuff you've got. That's why you should draw a triangle the very first time. All right, so what do I got here? Angle, angle, side, right? This time I got two angles and a side. Is the side in between the angles? No. So this is angle, angle, side. Is that okay? Yeah, so draw that triangle and just look where is everything positioned?
So now how do we tell the difference between ambiguous triangle and we spell off this? Because there's like the same words, but
So for law of cosines, the only time we start off with law of cosines is if we have all sides or if we have a side angle side, which I did not draw up here, but what would that look like? I don't want to do a 3069 triangle. Something like that, right? I have two sides and the angle that's in between them. So this would be side, angle, side. So here I would use law of cosines, right? And if I have all the sides and no angles, I use law of cosines. Okay? Yes.
And we still haven't found the area of the triangle.
Oh yeah, we didn't do area of a triangle. I should take that problem when I go to homework.
yeah, that's number 50.
Oh, it's number 50 on the thing? Yeah, I'll take it out. Don't worry about it.
It's 9 on
9 on the homework. The homework that's due tonight because I changed the due date. All right, I'll take that problem out. the area of any triangle is like 1/2 base times height times sine of 90 or something like that. There's two different ones, or you could do the square root of the difference of the squares of all the sides. Like there's two different ways to find it. We didn't talk about it. I'll take it out of the homework and I'll take it off the review and it won't be on the exam. Okay. All right. So we want to do some ask problems. Is that correct? Yes. Okay. Let's do some ask problems. All right, I just made this up. So we'll see what happens. All right, so, label. Boop, boop, boop. Okay, there we go. All right, so I'm given angle A is 63 degrees, side A is 6, and side C is 7. What type of information am I given? Angle side, right? Angle side, or side, angle. Since this is streaming live on YouTube, I don't know who's watching it. It's the only way I can get it to work. What's up? Oh, do what?
I found you were trying to see if you uploaded the videos on YouTube.
Oh,
and
nice.
So I typed in your YouTube and that was.
You found it, sure?
Yeah.
Sweet. Yeah. Cool. I should just record this. Can I record it? How do I do?
Once you like end the stream,
For real?
Yeah.
Cool. All right, cool. Well, it'll be on there. Ooh, then I really need to stop cussing. I apologize. Okay. All right. What's my first step? Determine if the given angle is acute or obtuse. What do I know about my given angle? It's 63 degrees. So is it acute or obtuse? It's acute. All right, cool. So my angle's acute. Angle A is less than 90 degrees. Got it. What do I do now?
now you determine if the corresponding to the given angle is longer than the other side.
All right. So now we have to determine if the side that corresponds to the given angle, how big is that side? It's 6. Is it bigger than the other side?
It's shorter.
It's shorter, right? So I have that side A is less than side C. So now I got to figure out how side A compares to what?
The height.
The height, right? Now I got to find the height. Y'all following that flow chart? Follow the flow chart? All right, so now I got to find the height of this triangle. So how do I, what's my height going to be?
It's your side or given side times sine of the angle given.
Which given side? The other one, right? So in this case, my height is going to be sine of the given angle, which is 63 degrees, times the side that does not correspond to the angle. So it's 7. So what is 7 times sine of 63 degrees? 6.24. What does that tell me? So now I have to compare, right? Looking at the side that corresponds to the given angle. Y'all following your flow chart? All right, what does it tell me? What am I doing? So the height is greater than the side that corresponds to the given angle. Right? We don't know. Yeah, since we don't know angle B, we don't know if side A is long enough to reach. And what did I just find? I just found the height of that triangle, right? A is smaller than the height. So what does that mean? There's no triangle. Right? A's not long enough to come all the way down. All right, I didn't mean for that to happen, so let's do another one. We ready? Okay. All right. So I'm given that angle A is 63 degrees. Side A is 6.5. And side C is 7. It's the first thing I do. Set up a triangle. So 63, 6.5, that's 7. What type of information do I have? Side side angle, right? Side side angle. All right. First thing I figure out. Angle is acute or obtuse. What do I have? Acute. I know that angle A is less than 90 degrees. So now I'm going to compare those side lengths. Is the side that corresponds to my given angle bigger or smaller than the other side? It's smaller. All right, so what does that tell me to do now? What do I have to do? I have to compare the height, right? So my height is going to be the other side times sine of my given angle. It's 6.24. Cool. Okay. All right. So now I got to make comparisons, right? And they're all listed out for you on that flow chart. And it's all based off of the side that corresponds to the given angle, which is what?
Smaller, so 2 triangles.
Right? So looking at 6.5 and looking at my height, the scenario that I have is my height is less than the side that corresponds to the given angle, and that side is smaller than the other side. When this happens, what do I have?
2 triangles.
2 triangles. So let's solve them. We ready? All right. So triangle 1. Always starting with my given information. Angle A is 63 degrees. Side A is 6.5. Side C, let me fix that. Side C is 7. All right. What's the first thing I do?
Use the law of sines to find it.
We use the law of sines to find the angle that corresponds to the other side, right? I have angle A and side A, so I have to use sine of A over A. And I know side C, so I can do sine of angle C over side C. Solve that, I'll get angle C. So I have sine of 63 degrees over 6.5 equals sine of C over 7. Cross multiply, divide by 6.5. I get sine of C equals 7 times sine of 63 degrees divided by 6.5. And what do I want to know? I want to know angle C. How do I get it? Inverse. So I get that C is equal to sine inverse of 7 times sine of 63 degrees over 6.5, which is approximately what? 73.65. Cool. All right. Now what? Find the third angle, right? I have 2 out of the 3 angles, so I could find the third angle. I can find angle B. So B is going to be 180 minus 73.65 minus 63. $46, 43.45. Cool. All right, so we found angle B, angle C. What do we have left? Side B, how do I do it? Law of sines, right? So I'm going to do sine of 63 degrees over 6.5 equals sine of 43.35 degrees over B. A little cross multiplication, a little division. I get B equals 6.5 times sine of 43.35 divided by sine of 63, which is approximately what is it?
5.0.
Anybody confirm? 5.01. Okay, perfect. So let's check. Does that make sense? What's my biggest angle?
Angle C,
Angle C. What's my biggest side?
side C,
Side C. What's my smallest angle? B. And what's my smallest side? B. Okay, so this seems legit. We okay with that? All right, we found the first triangle. Solve the first triangle. So let's look at the second triangle. So with the second triangle, triangle number 2, we start off with all the same given information. Angle A is 63 degrees, side A is 6.5, side C is 7. Now, remember the way that we can have, that we get these 2 triangles, right? I know angle A is 63 degrees. That's curving out all weird. Let's go like this. I know side A is 6.5, and I know here's A, B's over here, here's C, here's 7. All right, so because of the length of A and the size of angle C and the height, my side A, this angle right here, I can either, because of its length, I can sweep out like this, right? Or I can take that same length and sweep in like this, right? Sweep both ways. Okay, so how can that happen? This, remember sine. So the first angle I found is 73.65 degrees. First angle we found is 73.65 degrees. If I look on my unit circle, where's 73.65 degrees? First quadrant, somewhere right about here or so, right? And we're talking about sine. Where else will sine give me the same y value?
the second.
In the second quadrant, right? Over here. just reflect it over. Boop. So guess what? This length and this length are the same because it's just a reflection. So how do I find what this angle is? Because that's the angle that gives me the same value. 180 minus this distance. So we do the same thing every time. In the second triangle, I start with all the same information, and then I take the first angle I found, which in this case was angle C, and I subtract it from 180. So I'm going to start with angle C. This is going to be 180 minus 73.65, which gives me what? 106.35. Right, and so what we can see are two triangles. Our first triangle that we found, that angle was acute. So it was sweeping in. We found that smaller triangle. But now angle C, it could be obtuse. And so this one's sweeping out. We're finding that bigger triangle. Is that okay? All right, so I found angle C. I got angle A. What do I do now? Find the third angle, right? Find angle B. How do I find angle B? Right? Yeah. Very good. 180 minus 106.35 minus 63 gives me what?
10.65.
Cool. What am I missing? How do I find that? Law of sines. I still like to use my exact given information. So I'm going to say sine of 63 degrees over 6.5 equals sine of 10.65 degrees over B. Cross multiply, divide. B is equal to 6.5 sine of 10.65 over, very good, Quan, sine of 63, which gives me approximately what?
Yeah,
1.3?
1.3.
1.34? 1.35? Okay. Does that make sense? Yes. Why? Right. And by far is B the smallest angle. It's only 10 degrees, right? And the other ones are 60 and 100. So it makes sense that side B is only 1. Is that okay? And now we solved both triangles. And it works that same way every single time. Solve the first one with law of sines. Boop. Second one, given information. First found angle from 180. Solve using law of sines. Good? All right. What other questions do we have? Yes. So on your exam, remember, you can use the reference sheet I gave you that has the power reducing, double angle, half angle. Who's got their reference sheet?
It's on the blackboard. It's the first page.
Not that one. This one. Okay. This one. This one you can use, not the one that has 50 million things on it and the unit circle in the back. You cannot use that on your exam. You can use this one, and thank you. You can use your flow chart. Okay. When you walk in, though, nothing can be written on it. If you write stuff on it, I'm taking it from you and giving you a clean one. Okay. Once you get your exam, if you want to put the unit circle or whatever else on it, that's up to you. But blank when you walk in. Is that good? Yes.
That includes the law of sines and law of cosines?
Yeah, you can use the flow chart. Absolutely. Yeah, and I wrote the law of sines and cosines on there for you, so you can have that. That's totally fine. And the reference sheet. But you will need to know your reciprocal identities, your quotient identities, the Pythagorean identities, and the even and odd identities. Yes, ma'am.
On my flowchart, I just like used highlighters to color code it to make it easier. Like, is that fine? 'Cause I
That's
didn't write
fine.
any different information.
That's totally fine. Totally fine. I love the highlighters. Makes me happy. It makes me happy because that shows such organization. I don't have any of that.
Yeah, it's like my brain doesn't work if I don't use color.
It's beautiful. I love it. I love seeing people's notes and they're all like color coded and they got sticky tabs and stuff in it. I'm like, that's amazing. I don't do that. All right, what else we got, guys? You got one in mind? I'm so glad you made it so big. I'm so glad. All right, so things to notice. I have a single fraction here, right? What do I have here? Single fraction, right? So I don't want to bust it up because I still need that single fraction. Okay. This one has secants and cosines. What does this one have? Cosines and sines. I don't need secant, do I? Nah. So let's get rid of it. What's secant mean? 1 over cosine. All right, so I'm going to start with that. So I'm going to change all my secants to 1 over cosine. So I get 1 over cosine of x plus cosine of x. I'm going to put it over 1 since I got fractions now. Over 1 over cosine of x plus, minus. And I just used the reciprocal identity. We go so far? All right. Now, I don't have anything squared. I used the reciprocal identity. If I use it again, I'm going to get right back where I was, and that's not going to be helpful. What do I have going on? Just look at the top part right here. What am I doing? Adding what? Fractions. So we should probably add the fractions, right? That's what it's telling me to do. It's really the only thing I can see to do. How do I add fractions? Common denominator. So what's my common denominator going to be? Cosine. Look at the bottom. Same exact thing but subtraction. So I'm going to do it all in one fell swoop. So this already has cosine in the denominator. This already has cosine in the denominator. I have to force these fractions to have cosine in the denominator. How do I do it? Multiply by cosine. So I'm going to have 1 over cosine of x plus cosine squared of x over cosine of x over 1 over cosine of x minus cosine squared of x over cosine of x. Is that okay? All right, so now I have common denominators. So I have 1 plus cosine squared of x over cosine of x over 1 minus cosine squared of x over cosine of x. Has this gotten me closer to where I'm trying to go? Yeah, absolutely, right? I already have the 1 plus cosine squared that I need. Check. What else do I need?
Sine.
Sine squared. How could I possibly get sine squared? Pythagorean identity, right? So what does sine squared equal with the 1 minus cosine squared, right? Sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. Hey. So I'm going to have 1 plus cosine squared of x over cosine of x over sine squared of x over cosine of x. I'm so close. I'm so close. I have the 1 plus cosine squared. I got the sine squared. How the heck do I get rid of the cosine? Because I don't need it. Right? Look at the big picture. What's happening here? I have a fraction and another fraction. What does this line mean? It's division, right? Fractions are just division. So I can rewrite this as 1 plus cosine squared of x over cosine divided by sine squared over cosine. Right? You okay with that? We're dividing by this fraction. How do I divide fractions? Multiply by the reciprocal of the bottom. So I'm going to multiply this times this flipped over. So times cosine of x over sine squared of x. Now what happens? Cosines cancel out. So I get 1 plus cosine squared of x over sine squared of x, which is exactly what I wanted. Is that good? Oh, it's 12:30, guys. Oh yeah, y'all. Most of y'all already packed up. You knew it was 12:30. All right. Exam on Friday. About 8 questions. Y'all know what you can use. Come on time so you have the whole class to finish it. Group me, email me, whatever if you have questions before. And I'll see y'all Friday.
That talks about 4 different ways that people want to study. Let me post on the link and it gives you like ideas. And every time, so I post this for a lot of like my foundations courses, and every time people are like, holy moly, I have no idea. So let me send that and you read through it and then that'll be right there. Am I good?
Do you have any hours she's